I've completed the power wiring, which consists of, first of all, this green ground wire is connected to the metal outside of the power switch. Since we have 110 volts coming to the switch could fail, and the toggle in the front is metal and it would be hot. Could be hot. This way, with the green wire, it should blow the fuse in the IEC connector. Then from the switch I have a supply wire coming from the IEC connector. It's going into here, and one goes back and picks up the black primary windings. In order to take care of the red side of the primary, the other primaries, I have a crimp terminal that slides onto the IEC connector. I use crimp terminals and slide-on terminals for all the power connections. I've completed the fan wiring. You can only really see one fan. Two here are buried. There's one under the board. And I've completed primary wiring to the power supply itself. If I plug in the IEC connector, turn it on, no smoke comes out, that's good. This fan is running, and these two fans are running. I assume the fan underneath is running. So the next thing will be to take the output, positive and negative, and run it to the ammeter. Take the ammeter, run it to the appropriate jack. Take the center conductor and run it to the appropriate jack. Then take the voltage sample off. Probably I'll take it off the jacks. Maybe I'll take it off of here and run it to the voltmeter, which is in the center here. So here it is, all wired. I brought up the three wires, the positive, negative, and common, red, black, and blue. I went to the ammeter, and from the ammeter to the jacks, plus and minus jacks. I took the common and a sample from each jack and took them to the meter switching. And I have a schematic that's on the information package, but you can see the commons jumped. And you see that it's a 2-pole switch, double throw, and the common is jumped from the bottom terminal here to the top terminal on this side. And then the positive and negative, red and blue, are here. So that's how we flop the polarity of the meter. I'm just going to hold it here for a minute. I haven't put the case on yet, so, but look at the meter. It's a voltmeter, and you see it returns perfectly. I'll jack this up to exactly 15 volts on the meter. So both outputs are identical according to the meter. I now have it hooked to a dummy load. There's no neutral. I'm taking it across the negative and positive output. That means your current flowing through these meters is identical. I'll raise that up just a trifle amount. You can see this meter is just a smidgen low. And it's 15 volts. 15 volts. I'm reading positive and negative. If I had it to do over, I would put a load switch on here so I can set this up for voltage. It would be a single throw double pole switch so that I could turn the power supply on, adjust the voltage, and then power the load up. The other thing I would have liked to done, but I don't see a way to do it, would be to put a power on indicator somewhere. See how low this drops down. And so it goes down to just a little more than 2 volts before it begins to self-limit the current. It goes to a maximum. I haven't tried this yet. Of just over, with a load, just over 25 volts. My dummy load will only accept 30 watts, I think. So 15 volts, I should be able to increase the load to 1 amp or close to it. There we have 1 amp. My dummy load may shut down. I think on one of my parallel dummy loads I'm exceeding the wattage allowance. So at 1 amp I can get 24 volts. So there we have it. It'll take me a few days, but I'll publish all my documentation to a folder on my website, and I'll provide a link in the description.